In 2024, Reuters revealed a $1.8 billion classified contract between SpaceX and the National Reconnaissance Office. The NRO builds spy satellites for the CIA, NSA, and Department of Defense. The contract is for hundreds of satellites, designed to provide continuous surveillance of targets almost anywhere on the globe. Those satellites are part of the Starlink constellation orbiting above you right now, the same network SpaceX markets as internet service. Over 7,700 satellites are overhead. Most people paying for Starlink have no idea their monthly subscription is funding a surveillance system. China just started fining ships up to $72,000 for using it. Russia banned it completely. They can't stop the satellites from flying overhead, but they're trying everything to keep them from operating in their territory. How did internet satellites become a spy network? Most people think of Starlink as an internet service. You buy a terminal that looks like a small satellite dish, point it at the sky, and get broadband speeds in places where cable and fiber don't exist. Boats use it for navigation and communication. Remote communities use it for education and telemedicine. The service works because thousands of satellites orbit at roughly 550 kilometers altitude, low enough that signals travel fast, and latency stays below what you'd get from traditional satellite internet. SpaceX launches them in batches of 40 to 60 at a time on Falcon 9 rockets. The satellites spread out into their assigned orbital shells and begin transmitting. Each one weighs about 260 kilograms and has a lifespan of roughly 5 years before it deorbits and burns up in the atmosphere. The constellation is designed for redundancy. If one satellite fails or moves out of range, another takes its place within seconds. Coverage is nearly continuous across most of the planet. By the end of 2025, SpaceX had regulatory approval to launch up to 42,000 satellites total. That scale is what makes Starlink different from every satellite internet system that came before it. Previous constellations had dozens of satellites. Starlink has thousands, and that density creates capabilities that go far beyond providing internet access. But SpaceX isn't advertising those capabilities, at least not publicly. In December 2022, SpaceX quietly announced a new division called Starshield. The press release was brief. It said Starshield would leverage Starlink technology for government and military applications, including Earth observation, communications, and hosting classified payloads. The website for Starshield lists 3 core services. First, Earth observation with satellites that can carry imaging sensors. Second, secure communications using the same laser links that connect commercial Starlink satellites, but with military-grade encryption. Third, custom payloads that SpaceX will design, build, and launch for customers with specific mission requirements. What the announcement didn't say is that Starshield and Starlink use the same satellites. There's no separate constellation. The distinction is operational, not physical. Commercial Starlink terminals connect to the network and get internet. Government terminals with proper authorization connect to the same satellites and get classified communications or sensor data. The satellites themselves are dual-use platforms. They broadcast internet signals to civilian customers and relay encrypted military data at the same time. One network, 2 purposes. And most people paying for Starlink service have no idea their monthly subscription is funding a surveillance system. The full scale of that system only became clear in 2024 when journalists started digging into SpaceX's government contracts. In February 2024, the Wall Street Journal reported that SpaceX had signed a $1.8 billion contract with an unnamed intelligence agency. The contract involved building a classified satellite network, but no other details were available. 2 months later, Reuters identified the agency as the National Reconnaissance Office. The NRO is responsible for designing, building, and operating spy satellites for the US intelligence community. It works closely with the CIA, NSA, and Department of Defense. Most of its projects remain classified for decades. According to sources familiar with the program, the contract is for a network of hundreds of satellites that will operate as a swarm in low Earth orbit. The satellites carry Earth imaging sensors and can track targets continuously. The goal is persistent, pervasive coverage that allows the US government to monitor activity almost anywhere on the planet in near real time. The first satellites in the network began launching in 2020. By March 2024, at least a dozen had reached orbit. None of them were ever publicly acknowledged by SpaceX or the US government. They're launched alongside commercial Starlink satellites and inserted into the same orbital planes. From the ground, they're indistinguishable. In May 2024, the network became operational. A satellite designated NROL 146 was the first confirmed Starshield payload to go live. Since then, more have followed. The exact number remains classified, but job postings and budget documents suggest production is ramping up quickly. SpaceX is building the satellites at its facility in Redmond, Washington. The company hired former four-star General Terrence O'Shaughnessy to oversee the program. O'Shaughnessy previously served as commander of US Northern Command and NORAD. While still in active duty, he advocated publicly for integrating artificial intelligence and machine learning into military sensor networks to enable faster decision-making. That's exactly what Starshield is designed to do. The satellites feed data to ground stations, where algorithms process the imagery and flag targets for human analysts. The system is built for speed. Traditional spy satellites take hours to task, capture images, downlink data, and deliver intelligence products. Starshield can do it in minutes, and because the constellation is so large, coverage gaps don't exist. A target might slip out of view of one satellite, but another will be overhead within seconds. The system never blinks. The surveillance capabilities are only part of the story. The same satellites that provide internet and imaging also create a passive radar network that others can exploit. In September 2024, researchers at Fraunhofer Institute for High-Frequency Physics and Radar Techniques in Germany demonstrated a system called Sabia 2.0. It uses signals transmitted by Starlink satellites as illumination sources for radar imaging. The system doesn't send out its own radar pulses. Instead, it listens for reflections of Starlink signals bouncing off objects on the ground or in the air. Because Starlink satellites are everywhere and constantly transmitting, the system has persistent coverage. One satellite disappears over the horizon, another appears to replace it. The radar never stops. And because the system is passive, it's nearly impossible to detect or jam. There's no transmitter to locate, no beam to intercept. The German military tested Sabia 2.0 on ships and moving platforms. The system successfully tracked aircraft and other targets using nothing but Starlink radiation. The prototype uses a high-gain antenna to lock onto a selected satellite and copy its signal. Then a second antenna pointed at the surveillance area to capture echoes. China went further. In August 2024, researchers at Wuhan University published a paper demonstrating that Starlink signals could be used to detect stealth aircraft. Stealth designs work by reducing radar cross-section through geometric shaping and absorbent coatings. They're optimized to deflect signals from ground-based radars operating at specific frequencies. But Starlink operates at different frequencies and from different angles. The Chinese team showed that a ground-based receiver could use Starlink transmissions to illuminate a stealth target and capture enough reflected signal to track it. The target's shape and coating didn't matter. The sheer power and coverage of the Starlink constellation overwhelmed the stealth advantage. This capability terrifies militaries that have invested billions in stealth technology. It also explains why certain countries have moved aggressively to ban Starlink within their borders. China declared Starlink illegal in 2021. Any vessel entering Chinese territorial waters must deactivate Starlink terminals before crossing the 12 nautical mile boundary. In December 2025, Chinese authorities issued the first known penalty for violating this rule. A foreign ship was caught with an active Starlink terminal during a port inspection in Ningbo. The fine was undisclosed, but regulations allow penalties up to $72,000, along with equipment confiscation and vessel detention. The official justification is that unauthorized satellite communication equipment violates Chinese telecommunications law. All radio devices and frequencies require government approval. Starlink has never applied for or received that approval, but the real reason is strategic. China watched how Starlink performed in Ukraine and concluded it represents a surveillance and communications capability they cannot control or counter. Banning the service domestically doesn't stop the satellites from flying overhead, but it prevents ground terminals from operating within Chinese jurisdiction. Russia has taken a similar stance. Starlink is classified as illegal, and the company refuses to provide service there. Iran and North Korea have also banned it. These countries share a common concern. Starlink bypasses state-controlled internet infrastructure and creates a communication channel governments can't monitor or shut down. During protests in Iran in 2022, Starlink service was briefly activated without government permission, allowing demonstrators to coordinate and share information despite internet blackouts. Iranian officials filed international complaints with SpaceX, but the satellites kept transmitting. The government had no technical means to stop them. That powerlessness is exactly what makes Starlink threatening. Traditional telecommunications infrastructure can be controlled. Fiber optic cables cross borders at known points. Cell towers are physical installations that can be regulated or seized. Satellites in geostationary orbit are expensive, few in number, and easy to track. Starlink is none of those things. The satellites are cheap, numerous, and constantly moving. Jamming one doesn't matter when 10 more are overhead. Destroying one creates an international incident and barely dents the constellation. The system is resilient by design, built to survive interference and continue operating, and it has proven that resilience under fire. When Russia invaded Ukraine in February 2022, one of the first targets was communications infrastructure. Cell towers were destroyed, internet cables were cut. Ukrainian forces found themselves unable to coordinate across dispersed units or communicate with command centers. SpaceX activated Starlink service over Ukraine within 48 hours of the invasion. Terminals began arriving by the thousands, shipped from Poland and other NATO countries. By June 2022, Ukraine had deployed over 20,000 terminals across military and civilian networks. By the end of 2024, that number exceeded 47,000. The impact on the battlefield was immediate. Ukrainian artillery units used Starlink to connect targeting drones with fire control systems, creating a real-time coordination loop that allowed them to respond to Russian positions within minutes instead of hours. Infantry units on the front lines maintained secure communications with headquarters even when cellular networks were down. During the siege of Mariupol in April and May 2022, Ukrainian defenders trapped in the Azovstal steel plant used Starlink to send photos and videos to the outside world. The plant was surrounded, under constant bombardment, and completely isolated from traditional communications. Starlink was the only link that worked. In October 2022, Ukrainian forces used Starlink-equipped naval drones to attempt an attack on the Russian fleet in Sevastopol. The drones were essentially floating bombs guided by satellite internet. One washed ashore before detonating, and Russian forces recovered the Starlink terminal still attached to its stern. Russia tried repeatedly to jam Starlink signals. Electronic warfare units deployed equipment designed to disrupt satellite communications. The jamming worked sporadically near the front lines, but couldn't achieve persistent denial. SpaceX updated the software to resist interference, and Ukrainian forces adapted tactics to work around degraded coverage. By 2024, the Pentagon was paying SpaceX over $23 million annually to maintain Starlink service in Ukraine. The US Department of Defense also awarded contracts for thousands of additional terminals to support Ukrainian operations. Poland contributed 19,500 terminals, the largest single donation from any country. Ukrainian military officers have publicly stated that without Starlink, their communications network would have collapsed and the war might have been lost in the first months. That assessment was not hyperbole. Russia's military did not have an equivalent capability, giving Ukraine a decisive advantage in battlefield coordination. By late 2024, reports emerged that Russian forces had begun acquiring Starlink terminals through black markets in Dubai and other intermediaries. SpaceX claimed it does not do business with Russia and that the terminals must have been obtained illegally. The company eventually blocked service in Russian-occupied territories, but the fact that Russia sought access at all demonstrates how valuable the system had become. The lesson was clear. Control of satellite communications in a conflict zone can determine the outcome, and as of 2025, only one company provides that capability at scale. SpaceX holds over $22 billion in federal contracts across NASA, the Department of Defense, and intelligence agencies. In 2024 alone, the company received $3.3 billion in unclassified government revenue. Classified programs add an unknown amount on top. Starshield contracts account for a growing share. The initial $70 million Space Force contract in 2023 was only the beginning. By 2026, funding documents revealed a $13 billion ceiling for military satellite programs, with SpaceX as the primary contractor. This reflects a shift in military space strategy. Traditional spy satellites cost over $1 billion each and take years to build. Starlink represents the opposite approach. Thousands of cheap satellites with overlapping capabilities launched rapidly on reusable rockets. Treat the constellation as a resilient network rather than irreplaceable assets. This works because SpaceX controls both satellites and launches. The company manufactures Starlink satellites at roughly 6 per day. Falcon 9 rockets launch batches every few days. The entire pipeline is vertically integrated. No other entity has this combination of manufacturing capacity, launch cadence, and orbital infrastructure. SpaceX built it alone, and now it's offering access to governments willing to pay. Elon Musk operates a massive Tesla factory in Shanghai that produces roughly half of Tesla's global vehicle output. Chinese sales account for a significant percentage of the company's revenue. He also leads the Department of Government Efficiency, giving him influence over federal spending decisions for agencies that contract with SpaceX. SpaceX executives state that Starlink does not operate in Russia or China, but the satellites fly over those countries every 90 minutes regardless. The hardware exists. The coverage is global. Whether the company activates service in a particular region is a business decision, not a technical limitation. For now, Starlink remains a dual-use system marketed as commercial internet, with government contracts on the side. Most subscribers pay for internet and get internet. What the satellites do when they're not serving civilian customers isn't advertised, but the infrastructure is there. Thousands of satellites providing persistent global coverage, billions in classified contracts for imaging and intelligence, proven battlefield effectiveness in Ukraine, passive radar capability that others can exploit, and corporate control concentrated in one person's hands. Starlink is a spy network. The internet service is real, but it was never the only purpose. The surveillance capability was built into the design from the beginning, and now it's operational, overhead, and watching. What do you think about Starlink's dual-use capabilities? Let me know in the comments. If you want to see more videos like this, hit the like button and subscribe. Thanks for watching.